Another fab appears boasting 2-nanometer tech. Established only in 2022, the Japanese semiconductor company Rapidus began trial production in April of 2-nanometer chips for US giant Broadcom and plans to provide samples in June. How did Rapidus, in just 3 years, challenge the 2-nanometer process? Is TSMC on high alert or just laughing it off? Let Tech News take you inside the story. In August 2022, Rapidus was born in Japan during a time of global geopolitical turmoil. The US-China tech war and COVID-19 pandemic severely disrupted the global semiconductor supply chain. Also, advanced chip production is highly concentrated at TSMC. And due to Taiwan's geographical location, it is vulnerable to the risk of war. Thus, every country hopes to build a complete ecosystem, becoming self-sufficient from design to manufacturing to reduce reliance on TSMC. Japan, once a semiconductor powerhouse, is especially eager to try. Although Japan's chip manufacturing was absent for the past decade, its materials hold a 50% global market share, ranking first. Its semiconductor equipment share is over 30%, ranking second. If it can fill the manufacturing gap, Japan could return to the global advanced semiconductor stage. Besides Japan, another country worried about geopolitical risk is the United States. Besides ensuring supply chain security, the US also wants to prevent advanced tech from falling into competitors' hands. To face this challenge, the US began making moves, seeing Japan as a key partner. In May 2022, former US President Biden visited PM Kishida. They signed a pact on semiconductor co-op. In July of that year, former US Secretary of State Blinken and Japan's Trade Minister Hageyuda Koichi discussed semiconductor industry cooperation. In August of that year, the Japanese government gathered 8 private companies like SoftBank, Sony, and Toyota to co-found Rapidus. The establishment of Rapidus is thought to be linked to the US-Japan semiconductor plan, adding a new variable to the global industry. However, Japan's most advanced tech at the time was only 40 nanometers. How can Rapidus overtake the competition and enter the 2-nanometer process? Rapidus first licensed 2-nanometer tech from IBM and sent 140 engineers to its research base in New York for training. The technology provided by IBM is the gate-all-around GA architecture. Compared to the mainstream FinFET structure, it is considered to offer better performance and efficiency, a trend for next-gen tech, especially in AI and HPC. Also, EUV lithography machines are essential for producing 2-nanometer chips. In December 2024, Rapidus began installing ASML's EUV equipment. This was the first time Japan imported EUV lithography tools, with support from IMEC. Through these arrangements, Rapidus plans to trial produce Broadcom's 2-nanometer chips this April, aiming for samples in June. This rapid development pace makes one wonder if Rapidus could possibly challenge TSMC's advanced process dominance. Rapidus's 2-nanometer chip production uses GA architecture in partnership with IBM's Watson Research Center. But it's a research institute without mass production experience. This means whether the tech can be mass-produced remains a question. Although Samsung has already adopted GA, it still hasn't been able to solve the yield problem. For Rapidus, lacking mass production experience, overcoming this challenge is undoubtedly a daunting task. Also, EUV equipment is vital for mass-producing 2-nanometer chips. Although Rapidus got EUV in December 2024, how many more it can get is a key question. Besides tech and equipment challenges, funding is also a huge hurdle. TSMC's total investment in 2-nanometer exceeds NTD 2T. Rapidus estimates it needs 5T for 2-nanometer production, about NTD 1T. The Japanese government has injected 920 billion yen, plus 7.3 billion yen from private investment, barely reaching 1T. There's still a 4T funding gap, and TSMC's long-term customer trust is an advantage newcomer Rapidus can't shake in the short term. For Rapidus, the best-case scenario is that its 2-nanometer chips can be mass-produced, becoming an alternative to TSMC. NVIDIA chief Jensen Huang said last year he wouldn't rule out future collaboration with Rapidus to improve supply chain resilience. Rapidus is also targeting small and medium enterprises and AI startups that struggle to get TSMC capacity. It's now in talks with 40 companies. With the global trend of reducing geopolitical risk and boosting supply chain resilience, the founding of Rapidus carries high hopes for reducing reliance on TSMC. However, for Rapidus to achieve 2-nanometer mass production and capture market share, it must overcome technical bottlenecks, equipment limits, and funding gaps. This is a huge challenge for the Japanese newcomer. In the long term, from tariffs to the rise of Rapidus, whether geopolitical factors will gradually erode TSMC's competitive edge is a key issue for Taiwan to watch closely.